Hello everyone. I wanted to give you a quick update of what I've learned in Unreal Engine last week, and it's quite fascinating because it has to do with behavior trees and blackboards. So I was looking into how can I add AI behavior to background characters or to kind of enemy characters that inhabit the world that we as the player explore. And previously I've been able to make that happen by just having all the enemy characters find my location once every second and then just literally run towards me and try to hunt me down, as it were. And that's a little bit boring because that behavior can't really change. They can only find player's location and then just walk there and try to get him, basically, while shooting at him perhaps. But it makes for much more interesting background behavior if we can give our AI characters or our background characters some behavior that says, hey, if you encounter this, then behave like that, or do this, then do that, then do that. And behavior trees make that possible in Unreal Engine. And here's what I've come up with. I don't know if you've seen this video. This is posted on my other channel, 3D Shenanigans. And in this video, I'm spawning, I believe, 100 Unreal guys into the world. They're all falling down from a box type thing. So there's a random point in the box that's generated. Then they fall down, they fall into something called the nav mesh volume, and then they behave. And they all appear to behave completely random. And that's because they are. So first of all, they all have a random color. That's nice. Then they all have a random walk speed. That is also very interesting. So they don't all walk at the same speed. And they find their own locations and wander around almost aimlessly in the game world. Sometimes they appear to be talking to one another. That is not scripted yet, but I'm looking into how to do that. And in this video, I wanted to explain to you what I've done there in the background to make this happen, so that, I remember for the future and that how I've created this. So in a nutshell, they are following a behavior that as soon as they come alive in the game world as such, oh, he's coming towards me. They are finding a random point in the game world, and then they face there. So they turn towards that point and then they walk there at a random speed. Then they wait there for a few seconds, a random amount of seconds. These guys having a conversation with one another, and then they turn away and go. I haven't scripted that. That's just something that just happened by accident. So yeah, and then so these guys wait, and then the behavior repeats. So there's quite a bit of stuff going on in the background. Let me show you what's necessary to make that happen. So this is just a demo scene in which I'm not spawning these guys. They're just dragged in manually into the scene. And perhaps we'll start there with the enemy character, as I've called him. This is a third-person project as it comes out of the box, and I'm using the spectator pawn to play the scene. So that means I'm not actually seeing my own character. This is just the spectator pawn that is just lets me kind of zoom around like a drone. And so all these guys are just enemy characters here, and they are based on the third-person character, of which I've removed the camera and the spring arm. And then I've used that as an enemy character. Let's follow this guy and look at his behavior. So he's walking around over here. He's found his new location on the map. And as soon as he's gotten there, he will stop, wait a moment, find a new location, turn towards that location, wait again, and then he's going to walk there with a random walk speed. And everyone does that, and because everyone's random color and random walk speed, it looks kind of fascinating if you have like 100 guys doing that. So let's start with the actual enemy character. So that was literally just a duplicate of the third-person character. And everything is in this AI folder here. That's him here, enemy character. Let's see how I've made this guy tick. So the random color happens in the construction script. So every time a new instance of this guy is made, he gets a random color. I'm creating a new dynamic material instance, referencing the mesh, and then I'm using a random color value to add that to the body color parameter, and that'll overlay a color on his body color. The logo is unchanged, and that's basically it. Then I'm calling the randomized walk speed function, just because that way I have a random walk speed at the beginning when the character starts walking. This is a function here, randomized walk speed, over here. And it is also called by the blackboard. So that's the kind of interesting bit in a moment, the blackboard and the behavior tree and the blackboard combo. So they can call functions on my character. So this is the randomized walk speed function. I'm grabbing a reference to the character movement from here, and then I'm setting the max walk speed with an integer, or with a float rather, between these two values. So that's how they walk slow, that's how as fast as they can walk, and then that's how they go and walk. The other interesting parts here that's in the behavior graph, that's the rotate towards function. So this will make more sense as we look at the behavior tree, because it also calls this function in which we're basically getting a new location here, and that is being passed onto this character also via the blackboard. So that's where this public variable here gets a value. That's a vector variable, and we're essentially interpolating over 1 second or over half a second. I don't actually remember. Let's have a look. Yeah, over 1 second between the values of 0 and 1. That's what this timeline does. So this thing is whoops. There we go. This thing is a timeline, and it gives us a value between 0 and 1 that interpolates two other values with this exciting lerp node. So the lerp node is great, actually. It takes two like-minded values or structs and then interpolates one towards the other. And we don't need to worry about what values they are. So if we had a value between 0 and 1, it's fairly easy to interpolate between those over the course of 1 second. But if you had a value of 88 and 177 and you wanted to interpolate between those, that's less easy to make. And if you have like vectors or other structs that you're dealing with, that's really difficult to interpolate them manually. So this lerp node takes care of that for us. The alpha value is the output of the timeline. So that's the actual interpolation between 0 and 1. And that then interpolates in turn the A and B values. A very, very clever way to do this. And the A and B values are in fact two floats, which are the Z rotation value of our current capsule's current location. So we're looking at that point in space, and then we're getting this new location from which we're extracting the new look at rotation as such, which is kind of over there. And then so that the character doesn't just go flip over there, we interpolate these two Z values from here over to there. And that's how the character goes and turns before he does anything else. So we do that, we make a rotator out of that with the X and Y values left intact, and then we're putting that into our new world rotation. So that's what this relatively complex function does. The only other thing that remains to be done on the enemy character, on our character, is in fact in the class defaults. We need to give him an AI controller class over here. So mine's called enemy controller. That's this thing. And that means this character is now controlled by the AI controller rather than the player controller or something else. So yes, that's the only other thing that we need to do. And then as soon as this guy gets spawned, the construction script is run and he can be controlled then by the AI controller, which in return relies on the blackboard or the behavior tree to give this guy the new location to which he needs to walk. Very clever. So that's our enemy character. Then the next thing I wanted to talk about quickly is in fact the enemy controller. This is an AI controller, and that is really simple. It's just, as we've seen, it's in the enemy character, it's set in the enemy character, and then it just is being told, hey, run a behavior tree called BT enemy on target self. So that means every time one of these guys is spawned, the behavior tree is run. Without it, the AI controller wouldn't really, you could put logic in the AI controller, but I don't have any, so I don't think I have, no, I've got nothing in here. So this thing is only there to initiate the behavior tree. That's all we do in the AI controller. And then the funky stuff begins. So this is, oh yeah, this is my spawner. I can briefly talk about this. The spawning thing, that is something that that creates over time, creates more of these guys. So it's literally just the spawn volume. Let's start in the viewport here. Actually, this is the box collision, which I've called spawn volume. And it is here that we're generating a random point like somewhere high above the game world. And at that random point, we're spawning a character. And as soon as he is spawned, I think the most important bit to take away here is that we're spawning an enemy character. That's all really, with a behavior tree. And that's really all we're doing here. And then we're increasing the counter so that we can see how many of these guys are currently in the world. This is the script that takes care of finding the random point in the spawn volume, but not really related to behavior trees. So let's go and close that down again. So behavior trees and blackboards. This is the behavior tree icon down here, and this is the blackboard icon. These work in tandem with one another. So once set up, they both, I'll just open the behavior tree, and you can see that in the right hand, on the right hand side here, we have the blackboard that's associated with that behavior tree. And now I can literally switch to the blackboard up here. So that's how these two things are kind of relying on another. I believe a blackboard or a behavior tree can only have one blackboard. And the relationship is that the blackboard is just a collection of key value pairs, essentially. So up here, we have only one usable key in the blackboard, and it's called patrol location. It's a vector, slightly different from what I gather than a variable. So a key value pair is basically a key is the word that you look up, and then the value is something that comes out of it. And it's used for storage, really, in C-like languages. And you can have a key of location, for example, and then you can have data for that. And if you find the data for location, you need to know what it is, and then you can grab that again. It's a bit like a database value. It's a database. That's how that works. So self-actor I haven't made. That the thing made that, but patrol location is the vector that we're going to use later. And that's the only thing I had to set up in the blackboard. Then the more exciting stuff actually happens in the behavior tree. And this works, this kind of this magic thing that works from the root downwards and then from left to right. So it works from up to down and then from left to right. I've got a sequence here that's just called walk around, and the root kicks off and then starts this task first. Then it goes up back to the root. Then it starts the next task, goes back up here and so forth. Does all these things. There's little numbers here that if you hover over them, you see the sequence in which the numbers are worked at. And when the behavior tree comes to the end of this, it goes back up here, then goes back up another step and uses another sequence if there was one. So I only have one, but if we had multiple, I can just literally take my root node and say, in this case, I wouldn't say make a sequence. I would go drag off this and then make a new selector. And then the selector is the thing that gets that gets made. So then the selector would then go and do the walk around thing. And once the walk around sequence is done, it would go back up to the selector and then do another sequence from here perhaps. So I can go and put another sequence on here that also has these little tasks associated. And once walk around is done with, it'll go back to the selector and then it does this sequence and then does this sequence and so forth. So I didn't have to do that because I didn't have I didn't really need a selector. I've only got one. I can leave it in, I don't have to. But that's how a behavior tree works. That's very nice. And with the behavior tree, we can then go and give our little guys some behavior. So I've used these tasks here. BTT is just the preface for a custom task. If we double click it, we go into the blueprint of that task. And those are the things at the bottom here. These little round circly bits, those are all custom tasks. And they get created immediately with a kind of a brand new file. As soon as you click new task, for some bizarre reason, it no longer works. I don't know. I haven't quite figured that out yet. It looks like a bug when the behavior tree is kind of fresh and you're still working on it. This opens a new file and it comes up with a blank blueprint thing. It no longer does that. I don't know. So in this case, if I wanted to make a new task, I'd have to go into here and then go under artificial intelligence. No, not actually. I'm going to go under, I think this is a blueprint class, and we'll just look for task. There we go. Behavior tree blueprint base. That's what I would create. And then that would make me one of those circly things. Luckily, I don't have to do that. I'll just go in here and double click find new location. That's the first task, that a custom task that is being made here. And that opens up this. So it looks just like another blueprint, can have variables, local variables, public variables. Public ones are then accessible from the behavior tree. That's quite nice. And all these tasks start with a thing called event receive execute AI. So that's a bit like event begin play, but for a custom task. This is the thing that, kicks the whole thing off. This is actually the most complex of them all. We're casting to our enemy character. If we're not successful, we're finishing this task and marking it as not successful. That's quite clever. So we begin the task and then we can finish the task and then we can mark it either as successful or not successful. It's a value we can then test: has this task finished successfully or not. So if the cast failed, we abort. It's just a kind of fail-safe. But if we are successful, which hopefully we are saying grab a random reachable point in a radius from the actor's current location based on a radius that we set. Like that's pixels or units in, around the character. And this is a really, really cool note. It says, give me a point. No, it doesn't just say give me a point in this radius. It says give me a reachable point. And that's fantastic. That's our new location that we then get. They're called the random location. If there's a mountain in the way, or there's a cliff or whatever, or there's a gap on the nav mesh that the character couldn't ever reach, even though it's within his radius, that point would never come out. That's very clever. I like that about that node. So he would only give you values that are actually reachable. If it turns out the value isn't reachable, it would still fail. If there's too many people around him, or there's just not enough area to give you a random point, it could fail. And at that point, we would go over to the fail branch, the fail node of this branch. If we are successful based on the return value here, did it work or not? We're setting a new value of the random location in a blackboard. So that's why that blackboard is so important, because the task can now ponce off the value that's been generated and store it somewhere safe. Then it finishes, gets deallocated, but the value is still safe in the blackboard. That's why that is so cool, and that's why that's so important. So we grab this random reachable location, pop it in the blackboard under the key of patrol location, which is what we've set. That's perfect. Should this not be successful, we're still giving out a valid value, which is then just the actor location. We're grabbing that from here. So we're going to take out a value no matter what happens. Either it's actually somewhere where the character can walk to, or it's just its own location, and then we just move on. And once we're done, we're marking this task as successfully finished. So that's that little encapsulated little bit of code here. We're finding a new location that is now, for the behavior tree, reachable via this thing called patrol location on the blackboard. That's very cool. Now we can, this is where this becomes really exciting. Then the next task is also a custom task, which is the rotate towards task. I've already explained how that works. If we open that, it's actually fairly easy, because we're only calling the actual rotate towards thing on our enemy character. We don't deal with that code here. But so the way this works is event receive execute UI is our start. We're casting to our enemy character so that we can actually execute that function. And now we're setting the value of the new location inside our enemy character by way of grabbing it from a key called patrol location from our blackboard. So we take that key, out comes a vector. The vector we pop into our new location variable that's set on the character. So now the character knows the new location, and now we can just call the rotate towards function on him, and he just goes and does it, which is awesome. And then we can just go and say, hey, that task is now finished executing successfully. So these tasks, they don't have to be massive. It's just that sometimes it's easier to encapsulate functionality into tiny files, and then they're very easy to come back to later and understand what they actually mean. So I do like that. So the behavior tree can also, they can run these custom tasks here, the BTTs that I'm writing, but it also has some of its own, like wait is one of its own. So we don't have to get involved. We don't have to write a task for wait. We can literally just go drag off a node here and then go and wait. And that's a task that comes directly from the behavior tree, and it has its own value. So I'll go get rid of this. It has its own values like wait time in seconds up here, but it also has a random deviation from that time. So that's quite nice. So you're waiting 2 seconds, but you could also take half a second or a value off that or add it towards it. So my character will wait between 1.5 and 2.5 seconds here to make a decision, should I really walk there or not. That's nice. You can get randomness in directly in the behavior tree. That's quite cool. Once we're finding a new location, we're rotating towards it, then we're waiting. Once we've rotated, we don't walk immediately, we just wait a little bit, and then we go get the character the randomized walk speed task. This works very similar to the previous task. We're saying event receive execute AI, cast the enemy character. Because we don't have to set a value, all we need to do is call a function on the character and then say, we're done here. That's cool. Now he has the new random walk speed and he can start walking, which is the next task, which is the move to task. And this also is not a custom task. This is one that is built into the blackboard. That's quite nice that the blackboard can move objects around. All we need to give it is the new location, which is the blackboard key of patrol location. And that's it. Once we're there, once this task is finished executing successfully, the behavior tree will wait until that time. Once it is finished, it'll go back up here. So this is what this execute finished node does. Once it's done, it goes back to this thing, and then this node executes the next one. So as soon as this task is finished, it goes back up here, and then we go wait again. This time between I would say no time and 5 seconds. And that's how that works. So this is how the behavior tree and the blackboard work together. Blackboard stores the values that we might need to give to other tasks, and the behavior tree is literally just an amalgamation of other tasks in which we can make decisions based on what's happening. So I could amend this now and say that if you bump into somebody, I could set that here in a custom task. If you overlap with another actor, then turn towards that actor, and both actors hopefully would do that, and then initiate a little hello, how you doing animation for 10 seconds and then walk apart again. A bit like you see on these Grand Theft Auto characters in the street that come together, and in case they bump into one another, they have a random conversation, and eventually they say goodbye, move away from one another, and then, so that as a background action would just be very cool. And I'm looking forward to having a look at more of that, really, and seeing if I can work out how to do that. Just to finish this off, let me show you the park project here. It'll take a second to load in, but yes, this is the park project that has the spawn volume in, that spawns these characters, counts the characters, and then just makes them walk. I found this quite fascinating. I also found this very difficult to wrap my head around, I must say, but it is a wonderful way to give our characters automatic and random behavior, and I'm looking forward to making animations with this. Alrighty, here we are. Silver TM's unbelievably awesome park environment, city park environment. I can go and zoom out here. This is probably my spawn value. Yeah, this is my spawner, and it can take a max Unreal guys value down here, and that is how many guys we're going to spawn. So it's set to 100 right now, and the spawner itself, yeah, that just sits here and spawns people. That's all he does, really. Let's go kick this off and see it in action. I believe there is a 30-second delay before the spawner actually does that, but that's fine. We're going to just leave that and just have a look in the beautiful environment that we've got here. If you haven't picked that up yet, do so now. It is free. I don't know for how long. It might be free forever. I really don't know. But it's just I've spent hours just walking around in this virtual park, and it's just so beautiful. Everything moves and wafts, and it even has audio on it. There's some sample audio, and yes, that's just absolutely marvelous. So we've already spawned a couple of guys. Let me just see where they are. There we go. This is where they are. I will show you in a moment where they're allowed to walk. I believe I can't display that now. No, I can't, because I'm playing right now, and yes, I'll show you how to do that in a moment. So they can't roam the whole park right now, but yes, they will be able to do that in a moment. You don't have to make a large volume for the spawner. You could just have a spaceship pull up and then spawn a character from that, drop him off, and then the spaceship goes away again, that would be another interesting little animation. But yeah, you've seen this. It's on the 3D Shenanigans channel if you want to have a look at the whole video. It is quite nice to just literally look at this world and just see what happens here. The park environment itself, if we just move over here, absolutely beautiful. He walks by the water. That's very nice, isn't it? Yeah, have a look at the water over there. No, you're going over here. Okay, no worries. Fine. Yes, beautiful to look at. It's very performance heavy though, so I was thinking maybe I can build a simple twin stick shooter in this environment, but it's just so heavy. I'm not sure if we're getting 60 frames a second here with this environment, so you probably have to build your own level with less assets. But yes, let me show you the Unreal guy. Let me show you the spawn volume. I believe have I called it something? A nav mesh bounce volume. There we go. That is it. That's it. And it's kind of a box volume. It's better if you press P. That lets you see where the actual navigation is being built. And you can see that it has volume to it, so sometimes he could literally walk on top of this tree here. But yes, inside the green square, this is where they can move around. So the spawner is just over here. That's the spawner, and that's the volume that spawns the guys. If I were to move that outside the nav mesh volume, the guys wouldn't land on it, and as a result they would just stand there and not walk around. So we don't want to do that. Press P to not do that, to not see that again, the navigation mesh. And on the left hand side you can look for nav mesh, oh come on, mesh bounce volume. This is the thing that at least one of them needs to be in the level for the AI to work. And that is how I've implemented these blackboards. I hope it was a little bit entertaining and helpful and informative. It wasn't supposed to be an in-depth course into the matter, but I've just discovered it and I thought it might be a nice idea to put it on tape and tell you all about my latest discoveries with Unreal Engine. Join me for more Unreal Engine news as I find out, and thank you so much for watching. I will see you next time. Take care. Bye-bye.